Maybe see after that if I can go and put it in for you, but maybe, maybe not. All right. So, ladies and gentlemen, I went over the last example. And this one adds a little bit what sometimes my old math teacher used to call little curveballs to it. So we got to change up our approach. We're still going to do the exact same process. However, we do have to make a couple changes to what we're doing. Yes? Okay, we can go in. Okay, I'll deal with you in a second. So therefore, in this problem, I have 2x squared plus 7x minus 4. All right? So to do this problem, we're going to do the same exact thing. We first need to make sure we get the 4 onto the other side. So therefore, we can have our variable isolated. So I have 2x squared plus 7x equals 4. Now, the reason why I do this, yes, this is number 19 on page 59. Okay? So now what I look at this is, remember, when completing the square, we have to create a perfect square trinomial. That's why we complete the square, is to create that perfect square trinomial. However, we cannot create a perfect square trinomial when our coefficient of our quadratic term is not 1. So what I'm going to have to do is I'm going to have to divide by 2. I'm going to have to factor out a 2. Now, it gets a problem here because we have to factor everything on this left side out of 2. And 2 does not evenly factor into 7. So this is going to create us a fraction. It's OK. We just need to get used to using fractions. So I'm going to factor out a 2. And therefore, I get x squared plus 7/2 x equals 4. Now, is that the correct way to factor out a 2? Let's double check by doing the distributive property. Is 2 times x squared 2x squared? Yes. Is 2 times 7/2 x equal to 7x? Yes, because when you multiply across, the 2's would divide out, leaving you just with the 7x. All right? So when you want to factor something out and it doesn't evenly factor into it, this is the way that it's going to look like. All right? So now we have our terms, and I still need to create a perfect square trinomial. Remember, we practiced this. What is the value of c that creates the perfect square trinomial? So to do that, you have to take b, divide by 2, and square it. Well, in this problem, we got a little problem because we have 7/2 divided by 2 squared. So what is 7/2 divided by 2? Well, remember, to do a problem like this, when you have a denominator and then another denominator, you have to make sure you multiply by the reciprocal. So I multiply by the reciprocal of 2, which is 1/2, and I do that on the top and the bottom. Therefore, this can be reduced to 7/4. So really what I'm doing is I'm squaring 7 over 4. And then when squaring 7 over 4, that really means 7/4 times 7/4. So you can look at it as 7 squared over 4 squared, which equals 49 over 16. So that's my value of c that makes this a perfect square. So let's rewrite it in there. 2 times x squared plus 7/2 x plus 49 over 16. Okay? Now, remember, whatever you do on the left side, you have to do on the right side. So I still have my 4 on the right side, so I'm going to do 4. And then since I added a 49 over 16 on the left side, I have to add a 49 over 16 on the right side. And then here comes the important part that so many students forget. Yes? Here comes the most important point that students often miss, is they forget to multiply by what your 49 over 16 is being multiplied on the left side. See here, I'm adding 49 over 16, right? But I added it inside the parentheses. And my parentheses are being multiplied by a 2. So really, since I added 49 over 16 multiplied by 2. So on the right side, I add 49 over 16 multiplied by 2. Okay? Remember, whatever you do on the left side, you have to do on the right side equally. Okay, so now I can rewrite this as a perfect square. Now, how do you write this as a perfect square? Remember, the easiest kind of trick I always like to do is just take whatever my b divided by 2 is, and that's going to be your perfect square. You can think of it like this. X plus 7/4 times x plus 7/4. If you wanted to kind of work on factoring it, does that work? Does x times x give you x squared? Yes. Does 7/4 times 7/4 gives you 49/16? Yes. Is 7/4 x plus 7/4 x give you 7/2? If you do the math, write it out if you need to. Yes, it does work. But we don't want to write it like this. We want to write it as a perfect square, which is x plus 7/4 squared equals, let's go ahead and do this first. Let's do 4 plus 49 over 16. So the first thing I'll do is I'll multiply 49 over 16 times 2. Well, ladies and gentlemen, you could multiply across, right, and get 98 and then divide by 16. Or you could also say, all this divide the top and the bottom by 2. So therefore, I get 41 or 49 over 8. All right? So then I have 49 over 8 plus 4, right? Because we have to add it to 4. So how do you add 48 plus 4? You got to get them to be the same denominator. So you create your fraction as a denominator, and then you have to get, all right, so if this is 8, I need to get this to be 8. So you multiply by 8 over 8. So you have 49 over 8 plus 32 over 8, which ends up equaling 81 over 8. Where did I get what? 4 can be rewritten as 4 over 1. I just wrote 4 as a fraction so you could see how to add them up together. And yes, okay. Okay? Cool? All right. So therefore, yes. Okay. So therefore, I have 81 over 8. Now, I need to divide by 2. Right? So now, you guys remember, the whole purpose of this is getting it down to one variable, which we now have. So now I just need to use inverse operations. Before I can square root both sides, I have to undo my multiplication. So I divide by 2 on both sides. Therefore, I have x plus 7/4 squared equals 81 over 8 divided by 2. Again, we have to multiply by the reciprocal, right? So you guys should get 81 over 16 when you do the math like I did over there. Now we take the square root. Take the square root of both sides. You get x plus 7/4 equals plus or minus the square root of 81 over 16. Now the square root of 81 over 16 is the same thing as taking plus or minus the square root of 81 over the square root of 16. Well, the square root of 81 is 9, and the square root of 16 is 4. So let's write this up in two different equations. So I could have x plus, oh, I already subtracted the 7/4, didn't I? Oh, no, I didn't. So I have x plus 7/4 equals 9 over 4, plus or minus, right? Then I subtract 7/4, and therefore I have two equations. I could write x equals a negative 7/4 plus 9/4, and x equals a negative 7/4 minus 9/4. Okay, because remember, when you introduce the square root, you have to include the positive and the negative. So negative 7 plus 9 is 2/4, which reduces down to 1/2. And negative 7 minus 9 is negative 16/4, which is equal to negative 4. Huh? Isn't that a lot of fun? Any questions? You guys just acted like I killed you. Yes? I was just showing you that when you take the square root of a rational term, you can break that up into just the square root of the top and on the bottom. So I was just showing you that's how you can take the square root, or think of taking the square root of a rational number. Okay? Any other questions? Yes?
So a lot of it is just like simplifying?
A lot of it is a lot of algebra stuff, yeah. I mean, the whole completing the square is doing the b over 2 squared. But besides that, we have factoring, and we have a lot of fraction work. on a lot of these problems. So it's just getting used to the fractions, getting practice. Yes?
So what would you have to use for
Well, a lot of times when we want to solve an equation, right? And let's say it's factorable, but you can't factor it, right? So you can use completing the square. I just found my two x-intercepts by completing the square. Some of you remember the fact, if you guys could try to factor this on your own. Some of you might be able to factor this on your own. Some of you might not know how to factor it. Okay? So it's a way for us to find the solutions without factoring. Okay? That's why completing the square is helpful. All right? And then the second part, the answer to Michaela's answer.